Today we're going to be talking, my talk's called Man in the Front. So we're going to be talking about messing around with the Android operating system so we can do application security testing. A little bit about me, I'm Ray Kelly. I'm an ex-spy guy, Spy Dynamics. So I was with them back in 2002 writing WebInspect and did that for a long time, all the way through our HP acquisition. After that, I moved off out of there to some other startups. PureWire, which then got acquired by Barracuda, where we were doing content security, web filtering, basically. And then this opportunity came back at HP again, where they're saying, hey, we got this mobile stuff going on. It's a new thing. Everyone's doing it. It's like, wow, that does sound cool. Let's go do that. So now I'm back with the Fortify on Demand group there, where we analyze web apps. We also do mobile. So that's where I'm at now. I also have for my own experimental purposes, a couple apps in the App Store called MineChat. If anyone plays Minecraft, if your kids play Minecraft, they probably have this on their device. So something else I do just kind of for fun. Good way to learn. So agenda real quick. We're just going to talk about, why is mobile security testing important? What are the pitfalls? Why is it hard? That's the big thing. Why is it so hard? And then we're going to go looking into how can we fix that? How can we use the Android operating system to be able to help us with our security testing? Please feel free to ask questions as we go. No problem with that. So man in the front, it's kind of a weird, people are kind of thinking, well, I know what man in the middle is. No problem. Man in the front, try to wrap your head around it. So I have the perfect example of this from the 70s, actually, late 70s, a paper shredder. And so I was watching the History Channel a couple years ago, back when they actually showed documentaries before reality TV became a big hit. And they had one on the Cold War and some espionage stuff that was going on. And they told the story about this paper shredders that they had. And so in Washington, D.C., where there was a hotel where all the dignitaries would stay, kings, queens, presidents of countries, and they would stay in this one particular hotel. Well, the hotel was kind enough to supply them with a paper shredder because you got to shred your important documents. The thing is, these were manufactured by some three-letter acronym from the government. I can't remember which one it was, probably CIA. And what they actually did was build a scanner inside of it, right above the shredder. So as they're shredding documents, it's reading the document and sending the bits over the electrical line to another room in the hotel where they were putting it all back together again and then storing those documents out. So in a way, if you think about it, it's kind of a man-in-the-front attack, right? It's doing that before encryption, albeit this is a one-way encryption, I think. Paper shredding is probably considered that. So I thought that was the coolest thing. If I wasn't in security at the time, this would have gotten me into it. Just watching that one documentary and seeing this paper shredder, I was like, that's cool. I brought this up to a friend of mine, a colleague that works in federal. And I was telling him the same story because it's kind of federal related. He goes, yeah, well, who's to say they're not doing that now? And I was like, interesting. Why is my paper shredder hooked up to an Ethernet cable? Cloud-based shredding. So challenges of mobile testing. Before we get into that, I'm just going to talk about some of the challenges we have, and then we'll see how this is going to address that. As far as the importance goes, if we look at these right now, mobile's hot. Everyone's doing it. It's the biggest thing right now. Everyone's rushing to get out there, and it's, if you're looking at any development group, it's probably mobile that's going to screw up the most right now, and that's for a couple of reasons. One of which is you're getting pushed by management to say, hey, we need a mobile app right now. Get it out there. Our back-end's secure. We don't care about that. Whatever you do on the device, just make sure it works. So that causes problems. Also, the developers don't require training, as much training to make mobile apps. Anyone can make mobile apps, especially now when you have PhoneGap, Xamarin. The app I mentioned that I wrote, I did that in C# on Xamarin, where it compiles down to a native binary for iOS. Piece of cake for someone like me who's probably a pretty horrible coder, but it made it very easy. A lot of people assume, hey, our mobile app just talks to a backend. So, it's not something that gets indexed by Google. No one goes to that, so don't worry about the API calls on the server side. No one's going to see that, right? So, people think it's safe because of that. When we look at mobile apps, it's the way we look at it in our group is there's 3 different layers that we have to look at very carefully. One is the client, of course, the device itself. What's being stored on the device? Is it sensitive? Is it encrypted? What's going on there? Are they validating certificates? So for the API that they're talking to. Next, we have the network, where, again, probably most of you are familiar with, where you're looking at network traffic and looking for data leakage, making sure they're over SSL, nothing clear text, pretty standard stuff. And of course, the server side, which everyone is familiar with, where we're looking at all the typical stuff that goes along with normal web application security, SQL injection, cross-site scripting. All that still applies to mobile tests. And when people say, hey, test my app here, oh, we need to log into your website or we need to know the URL. Why do you need that? I want you to test the mobile app. Well, that's all part of it. So really for a proper end-to-end assessment, you need to look at all 3 of the layers. So looking at some of the challenges, why is it hard? So if we start on the back end, the server side, again, all the same, path traversal, SQL injection, all that stuff still applies here. So you still need to check for that. Typically, you're using some kind of SOAP or RESTful API to get data back and forth. So to do that, you're going to need some valid credentials. So you do need a man in the middle, typically, to be able to get what does a valid request look like. If you're doing black box type testing, they're not going to probably give you your schema, your structure for the API. So you're going to have to get that somehow so you can send some valid data, or else you just get, I'm going to flag 1,000 server error findings in my report, which is not useful at all. So we need to do that. And it's pretty difficult with a mobile app if the mobile app was done correctly. So they're pinning the certificate, they're validating it, and it's like, well, how the heck do I get in the middle of that? It makes it very difficult. And there are ways around it for mobile apps for both Android. Like Android, you can rebuild the app and modify the code so it accepts certificates. That's a pain in the ass, though. On iOS, there's a couple ways to do it on your jailbroken device. But then you have the problem, well, now they have jailbreak detection built into the mobile app. Well, now it just got even harder to do it. You're like, oh, geez, another one. Looking at over the network. Again, typical stuff everyone's most familiar with, looking for data leakage. Typically, same thing, we need a man in the middle to be able to see this. This is an example of an assessment we did where this mobile app for a boy band, think New Kids on the Block back in the day, a real popular one. And their target demographic is probably girls 10 years old to 18 years old. And so he's testing, and he's man-in-the-middling this and being able to look at it. They didn't pin the certificate, so you could man-in-the-middle it, which was bad, but it was good for us because it makes testing easy again. And he's looking, web traffic's going by through his proxy logs, and all of a sudden he kind of glances like, what the heck was that? He scrolls back, and his home address was being sent over the network, and he never entered it into the app. And he's thinking, why in the world is this app doing this? And he looks like, it was his street name, I mean the full-on address. And you're thinking, why in the world do they do something like that? So, I mean, that was definitely, the creep factor was high there. Maybe they send GPS coordinates or whatever, but when you see your home address flying across the network, it really kind of opens your eyes. So now we're on to the client, and this is kind of where the black box kind of starts, where you're not really sure what's going on the client, right? I mean, you can monitor the traffic, you can kind of poke on the back end, but on the client, we're not sure what's going on always. So this is the unknown, what's sensitive input. And really, the only way to test that, you got to use the app physically. I need to actually exercise the app and find out what's going on. There's no web inspect to go just throw it a back end or whatever. So this is kind of a manual piece at the moment. I think there's some technologies coming along, and we're working on some things in our group to help automate mobile testing, but that's still in its infancy as far as I'm concerned. People are like, well, I'm right in there. I'm in the sandbox. I'm in good shape here. No, that's not true. Once you're jailbroken or rooted, that data is everywhere. And in fact, there's a talk coming up at Black Hat on where there's a vulnerability in Android 2.1 where any app can reach across the sandbox on not rooted devices and steal data. So that one's going to be, I'm excited to go see that one. Looking at what's getting written to the file system, everything gets written to it, right? Credentials, date of birth, all kinds of private information, sensitive photos. So we're looking there. And then not only the file system, so we talked about web traffic, file system, and then you have SQLLite. You know, in SQLLite, apps are using that all the time. The device uses it itself, like when you're using WebKit as a wrapper, say like in PhoneGap or something like that, or writing your own WebKit application. It automatically, as a helper, caches things. You know, it's doing caching. And when you have your credentials stored in the GET string, the Envisium guys yesterday showed the dating application. One thing I thought was interesting is it was sending the username and password in the GET line in the query string. Well, more than likely that also got stored to a SQLLite database somewhere because it's just trying to help cache things and make things faster. So so SQLLite is another target that we need to be real careful of and examine that closely. Oh, the example here. Anyone familiar with that? The RSA? The IO Active guys found this, so RSA this year, they had a mobile app, fantastic, and you download it and it shows you the schedule and who's presenting at what times, and what they did is instead of querying the backend, they shipped the entire SQLLite database down to the device. But not only did it have what time they talk and what their talk's about, it had who they work for, where they live. I mean, it was like their full-on speaker database. So that was it's awesome that the IO Active guys found that. Good stuff. Any questions? By far, through all of the testing that we do, the most egregious offenses are the client-side storage, what's getting stored on the device. And again, we talked about some of that stuff. What's getting stored in the SQL, what's getting stored in plist files, because they're easy. Fair to use keychain, I mean, I don't know if I've had more than a handful of apps that actually use the keychain for storing credentials, which you should do, but they don't. Here's another example too, where we had an assessment for a banking application. And they had a great feature where you can take your mobile app, take a picture of a check, and deposit it. Anyone do that before? Anyone using that feature? And so, okay, that's great. So we analyzed that, and what we found is they were not storing the photo to the sandbox, they were storing it to the public photo storage, where any app can go get access to that. Okay, so if you could imagine, you're pulling that stuff off and I'm just going to print me out some checks, Photoshop my name. I mean, that was just wide open. Looking at where that storage is and where that's happening. Interesting enough, on that, we sent the application back. And we said, we flagged that as a critical. Hey, you guys really got to fix this. Stop storing stuff in the global storage for photos. And okay, yeah, we'll fix all that. That's good. So they send it back for a remediation test, and we're looking at it, and yep, they sure did fix that. Okay. And so we kept testing, and what we found is there was another feature in the app where you can look at previously deposited checks, and you can sit there and flip through your phone and look at them. As you're doing that, it's writing all those things right back out to the global storage again. So we had to send it back again. And pressure on mobile developers. They're telling us, hey, we need this back today because we're shipping to the App Store today. And we're going, no, don't do it. So the pressure to get in there. So all that stuff I was talking about, like the SQLLite databases, the files, so how do you know what's happening when I'm using an app? There's no real tracing. There's nothing to really help you. You go exercise the app, and then you go back and you look on the device and try to look for stuff that looks interesting. Another example of that, where we exercised an app, and this app was so secure they had voice recognition for login. You say, hi, my name is Ray, and the app would log you in. And we looked at the app, and luckily the tester was real thorough, and he goes back into the device, starts looking at all the file system, look what's going on, and in their directory they found a file that had some bizarre extension on it, PXX, something that just didn't make sense. And he's saying, I wonder what is that? I got to go figure it out. Did the app even put it there? And so he takes it, throws it into like a hex editor, opens this thing up, and he noticed that there's MP3 headers in there, MP3 tags. And he's like, oh, that's interesting. So he pulls that file off onto his computer, renames it to MP3, and plays it, and sure enough, it's the voice. And what he was able to do is take the device, hit play on his computer, and it unlocked the app. So, that's another example of where developers, what the heck are they doing, right? They thought it was obscured by the file extension. That makes it secure. So here's where so I'm thinking about that. I saw Evan's talk this morning. It was real, it was inspiring. It was interesting. Like there's MacGyver, right? Here's this hard problem we have. It takes a long time. It's a pain in the ass. How do we do this better? There's got to be a way, and I'm just trying to think of different things. I'm like thinking, well, Android's open source. Why don't I take it and make some modifications and try to intercept some stuff to make our testing easier and see what's going on under the hood of all these apps. Again, those big challenges we're trying to overcome is certificate pinning, root detection, where is stuff going? So those are the challenges, and I was like, there's got to be an easier way to do this. So I started looking into it, and the trick is I was trying to see how low I can go into the operating system without doing damage because I'm not a C or C++ coder. And so I started looking into it, and it turns out that in the operating system, the core libraries object there, that's actually all in Java. I was like, I'm a pretty good hack at Java. Maybe I can take a look at that. WebKit and some of the frameworks, the SQLLite framework, is also in Java. And that's built in. So like file access, java.io, that code is written in Java. So I was like, let's see if we can do that. So I started this task, and I thought, man, this is going to be awesome. I'm going to go on to GitHub, do a big old clone, build that thing, and I'm off and running. Man, it was so hard. It literally took me like 2 weeks to get a good build to work. It was not easy, but it is easy if you know what to watch for and the things not to do. The platform was important. Don't diverge from what they say. So I had to spin up a VM with exactly Ubuntu 12.4, 64-bit. Okay, that's cool. They say they work on Mac. You can build on Ubuntu 10. And then you read all these posts in the groups. I'm like, oh, God, this doesn't work, and this is unstable. I'm like, oh, man, okay. Just give me something that works. So finally, I narrowed it down through all this experimentation that worked out best for me. Sounds crazy, but follow the instructions. They're probably about that long. Because you have to install all the third-party libraries, and they go through the list. It's pretty thorough. Most of it you can do like apt-get to pull that stuff down. So it wasn't hard. Again, it was just that initial trying to figure it all out. But there's a great page there where they start from downloading it, install the repo. It was not just a git clone to pull it down. You have to use their tools to actually pull the code down, because you actually say, give me Android 2.4.2 or whatever, and it'll pull it all down from their repo. So once you have it all down, there's really 4 steps to build it. And this part, once you get past all that stuff, it works out to be pretty easy. There's a set up the environment. So there's this command in here, and it sets a bunch of directories for you, paths and such. The next thing is you need to run a lunch command, and this is where you would say what it is you're actually building. And you can see how helpful it is over here on the left, where you can do a full build, one for VirtualBox, user debug. Don't use any of that. So I spent my wheels doing this, and like, God, nothing is building correctly. I'm not getting the SDK. I need the emulator. I need all this. Apparently there is a huge collection of hidden lunch commands that you have to go search and find. So eventually I found lunch sdk.eng, which you see is not in the list, where if you just type lunch, you just type it in and it works. So it sets it up, and you can see it's setting up for an ARM build. Yeah, so that got that going. So that's ready, and both of those steps takes like 10 seconds. It's pretty quick. Now we actually start the build. Now we've told it what we want to build, we have environment set up, and now we say run with it. And you can say Win SDK, which will give you the Windows SDK, or the SDK, which will be for Linuxy type systems, or even Mac for that matter. And then you wait about an hour. And finally, you get, hopefully, if you installed all the third-party products correctly, you get success. You can see here, it's actually handy. They actually do a zip of the entire directory. And once you unzip it, it looks exactly like what you download from like Eclipse when it sets up the emulator and such. You can see there's the SDK manager, the AVD manager, and it also packages the system image that you made your modifications on, which we're going to look at next. So it kind of packages it all up neatly. You extract it, and it just all works. So this one I spent another week on. So people familiar with the emulator? Android emulator? Use it? No? It is painfully slow. If anyone's used it, it's unusable, okay, as it is, based on the ARM version. But they do have the i386 version, which you can build, and it's pretty sweet. It's definitely more usable for testing apps and testing your own apps especially. I guess most people test on physical devices because that is blazingly fast. I find this to be pretty acceptable, the i386 version. There's very little documentation how to build the SDK for that. So again, it was kind of a search and destroy mission to try to go figure it all out. Again, it was another hidden lunch command to say what you want to build, SDK x86. So it'll build the x86 version of it. And you just say make SDK, same thing, build process, but now you've got it, now when you go look in your emulator and the targets, you'll see that it says Intel Atom x86 there. And so that's how you do that. So now I was feeling pretty good. I've got a build, I can build it, it works great, it's there. So now I'm going to get in there and start writing some code and trying to do some cool stuff. So the one thing I did to start with, again, I'm not a Java programmer either, so I'm just kind of hacking at this. I created my own. By the way, you'll see Shadow OS. This is just kind of what I called this this new operating system that is going to be our testing platform. I created a file called Shadow OS to do all the communication work, to do the things like logcat. So what I'm going to do is whenever there's an HTTP request, I'm going to say, hey, Shadow OS, here's an HTTP request that just went out, and go write it to logcat or to some other monitoring system. Okay, great. So I've got this library. It was kind of cool. Didn't expect it, but I was like, I wonder if I can just dump this in the build directory and if it'll get compiled in. And it did. So now I could go java.io.shadowos.log, and it just works. I was pretty shocked. I didn't have to change the build scripts or anything. It just got thrown in there. So for modifications for HTTP, this is where things kind of get quirky because there's not a lot of standard there for Java as far as libraries and such that you want to use. I found two main ones with apps that I were testing. You could use either java.net or apache.http. And so I found both of those source code files in there. And I just, as a request goes out, I grab it. And you can see, it's kind of hard to see maybe, but you can see where I grab the host name, I grab the headers, and the post data of the request that's going out. And even if it's over SSL, this is before encryption. So I can grab this now and take it and go log it out and send it somewhere. So that was, and that's all the code there. I mean, it's very small. You don't have to do a whole lot. For the file system, this one's a little bit better. For the most part, I found that most apps use file input stream and file output stream, to write to the device actually. And so again, super easy. You can see shadow OS log file.toString, which gives me the full path of the file that's being accessed, whether it's read or write. It just gives it to me, and I say, okay, great, go send that out, and let's go log it or do something with it. Yes? Yep. Yes, that is correct. So the emulator was the same. It does build the emulator, but once you kind of get it done once, then you can make Java changes in the OS and just grab the system image directory and just copy that right over, and every time, and you're good to go with your new. Yeah, you do recompile it, but we only need the image at this point. We've already built the emulator, and all that's cool. So we just want the system image now. Yeah, that was a good question. So that's file system. Were there any other questions about kind of related to that? No? Okay. SQLLite, this one was, I thought this was going to be brutal, dealing with SQL and trying to jump in there. This was actually the easiest one. So there is in the framework directory on, and you can see in the presentation I included the actual path to it under the repo where you can find the file. And there's SQLLite database Java. And again, this was kind of search and destroy. Right? I'm like grepping through the directory trying to find, okay, show me something with SQLLite so I can figure out where this is at. And I found this one file which does everything. Opens the database, handles inserts, updates, deletes. And just on the call, for instance, this is an update call. And during the update, I say, hey, log SQL.toString. And there's the SQL statement. Boom, log in that now. Build that into the OS, and now I'm intercepting that. So that one was pretty easy. It's that thing, right, where things you think are going to be easy are incredibly hard, and things you think are going to be hard are really easy. This was a perfect example of that, this entire project, where everything, I just want to build, and it was really hard, and I'm thinking, oh, SQLLite's going to be so hard. It was a piece of cake. So monitoring. So now we're capturing all this stuff. Now we have access to SQLLite, file system, and requests, HTTP and HTTPS requests. Now what do we want to do with it? And so when I first started working on this, I thought, well, the easiest thing is logcat, piece of cake, right? Just throw it out to logcat. And so with logcat, you can have in there where you can put a tag, so it's easier to filter out, filter all the noise out. I just want shadow OS requests, and that's something that I put in the logcat command. And it's probably hard to see because this isn't pretty, of course, logcat. But in here, you can see file access write, and it shows the name of the file that's being written to the device. Here, you can see there's a HTTP request, and here's the get line. Here's the headers, Crashlytics. A request is going out to Crashlytics. And near the top, you can see SQLLite update, where it's showing a SQLLite query. Update, user value, set value, so it's the whole SQL command line. So that's kind of what that looks like. And I was like, great, man, this is an OS now, and it's not rooted, so root detection isn't going to work because it is the OS. So if apps are doing that, it'll still work. We're before encryption, and we're watching everything, and we don't have to mess with apps anymore. Just whatever, any APK you get, drop it on there, and all of a sudden you're getting all this stuff. I didn't have to rebuild the app or tweak it or wrap it or do whatever. It just works. How about remote monitoring? I'm a Windows guy. Oh, the credibility just dripped, right? It just kind of went down. So I'm not all about the command line. I need GUI. So I was thinking, okay, now we need to get this stuff out into something that's usable. So what I did is in my, right after logcat, in my Shadow OS library, I said, hey, let's just open a port and dump that over somewhere where someone can be listening, where you can use the tool of your choice and do something cool with it. What I did is I took the data, wrapped it in XML, and then shot it out over a port that I picked to some listening app, which I'll show you, that I made. It was interesting that one of the biggest challenges was getting to that device, getting to my monitoring app, because even though the emulator is running on my PC that I'm listening on, the first thing I tried, obviously, is 127.0.0 localhost. Send it to localhost so my monitoring app can grab it. No, that routes back to the Android device. I was like, man, what in the world? So I started looking at host file. You can push a host file over, but that was kind of sketchy. Like, it would work sometimes, it wouldn't work. I kept getting out-of-memory errors trying to start the emulator when I would try to push the host file over. So that was sketchy. And then just before the conference this week, I was still struggling, how am I going to get this demo to work? Because I don't know what my IP address is until I get here. I have to rebuild the OS to point back at my interface. I found that the emulator actually has a loopback address to 127.0.0.1 on your machine, and it's 10.0.2.2. Out of nowhere, just one of these random things I stumbled on, like, great, and it works. So using 10.0.2.2, I got my monitoring request to come back to my machine. So let's go ahead and do a demo here. So again, I'm dirty, C# in Windows. Credibility just went down again. And we'll do a start. So I just whipped this app up just for fun to watch this stuff. It's ugly, but kind of gets the point across. And we'll crank up the emulator here. Resize everything. We'll give it just a second to warm up. It does. That was another thing that frustrated me. Why isn't the keyboard working? But when you set up the image in ADB or in the AVD manager, when you set up your image there, you have to say enable keyboard and it'll work. So there we go. We see things just starting up. We can see SQLLite queries, path access, and look at this: web requests, Facebook, Twitter. I've got a bunch of apps on here. I haven't even opened the apps up yet, and look, requests are going out. Oh, disclaimer, by the way, we're not pen testing any apps here. We're just using them under normal scenarios here, just monitoring what's going on the device. So just want to make sure that's clear. But as you can see, we've got requests already going out. I can click on these and actually see the requests. Notice this one's over HTTPS, but yet I've still got the data because we were grabbing it before encryption. Please don't steal my session state till after the presentation and wreck my Facebook profile. So cool. So we got some stuff there. So we'll go down here and we'll go ahead and jump in. Sorry, the screen's kind of start Facebook. You can see more stuff's happening now. Here's a SQLLite query happening. More requests to Facebook. If we look here, you can see I'm saying if it's an insert, open, or update. Here's an open. Facebook Katana, databases, notification, DB. So now that's something for, as a pen tester, that, hey, that's a database I should be interested in. Facebook is reading that thing. It's there. Let's go check that out. So it's kind of giving you clues of what things you should be going to look at. I was also dumping out the SQL query and the parameters in here as well. Insert into bookmarks, so we can see exactly what the app's doing. We'll go in here. We'll look at Joe Tester. He's a big RVAsec fan. And we can see more requests went out. It's writing files right here to the cache directory, images. So it's probably caching all the images to the device, so it doesn't have to go back and get them again. So we're able to see that. And even as let's see if we go back to our news feed. And I'm going to scroll, Doctor Who, he likes the World Cup. I'm going to keep, you can see things are happening here. We're still capturing data as we're using the app. And again, I can go back now and analyze the traffic and see what's going on. So that's kind of, as far as I went there, you know, some, if we look at some to-dos, let me jump back over. One of the things is I want to, you know, like the file access. So when I see that, I like to be able to go grab that file and pull it over with the tool. This tool can do a lot more stuff. I just haven't gotten around to it yet. Maybe two-way communication. Since I'm on the OS, I can open. I have a socket open. I can go back to it and say, "Hey, just give me Facebook," or "Hey, filter this out," or do something different. You know, so you can actually interact with the operating system real time. Would be pretty cool. Interception of more content. Let's say contacts, geolocation. All those libraries are in there that we have access to now and can build our own code into it to monitor. Let's see, logger upload of applications. I mean, this could be a real full-on pen test tool if, you know, put some time on it and just say, hey, logger, upload this file. Great, now I can go open it and monitor what's happening to it. Any questions on the logger?
Yeah, actually, I was just wondering if you were just saying about logger integration with like burp and things. I think it was like sending it and then you would inspect it in the burp.
Exactly. Yeah, thank you for pointing that out. I just missed that. So he was asking about integrations. Yeah, it'd be great to right-click on this, send a burp, send a web inspect, this request. And now I can go play with it in there. And that just made my job a lot easier than trying to go man in the middle and figure it out. But right from this monitoring tool to be able to kick these requests into some other tool. So yeah, absolutely. And that is the end of the presentation. My handle is VB is best. There goes the last bit of, yeah, that's the last bit of credibility right there. Feel free to follow me. And that's it.